Welcome back to the Exploring Your Universe radio show. Exploring Your Universe is Los Angeles' largest science fair. Last year we had over 12,000 attendees. This year we will be on Sunday, November 8th, 2026, in the same place, the Court of Sciences. Everything else, the same time, same channel, but we are the second Sunday this year. At Explore Your Universe, you will see so many booths, and one of them is probably going to be full of sand with a huge, long line. Very colorful, very, very busy, and it might be led by today's guest, DJ Tsu. DJ Tsu, that's Tsu as in tsunami, aka Lizzie Tsu, is a board member for the EPSS Family Mentorship Program, and last year she led the sand booth, stratigraphy in a jar, which is notoriously one of the most difficult booths to lead. So welcome, DJ Tsu.
Thank you for that introduction.
Of course. So if I recall correctly, you were a volunteer in the speaker room 2 years ago. Was that one of your first EYU?
That was, and I was very excited to found it my sophomore year because I was, it was lots of fun the first time around, and then I was really happy to be able to take over a larger role this past year.
Oh, actually, I totally remember this. I think you were like the only volunteer I accidentally yelled at 2 years ago. Really, really sorry about that. It happens when I have to talk to like thousands of people, but I was always like, oh, I hope that one volunteer isn't like super in their feelings about me being frustrated with them. Luckily, that didn't happen, and you took on a much larger role this past year. So what was that like for you? Had you ever seen an EYU booth before that?
Because I was a speaker volunteer, unfortunately I didn't get too much opportunities to interact with like the different booths and demos, but kind of had a vague idea of what was going on. It was my first time seeing the stratigraphy in a jar booth take place. And
yes.
Although the former booth leader, Val, had sort of warned me about how it was going to go down, there'd be a lot of kids, and it'd be really chaotic, I think I wasn't fully ready for the absolute like scale and the number of people who'd be everywhere wanting to create their stratigraphy in a jar.
To be fair, I don't think anybody could ever be ready for that booth, but yes, shout out to DJ Super No Val. I don't think the booth was her idea, but she definitely is like the face of that booth and has been for several years until you took it over. Do you remember how many kids actually visited you?
I don't remember. I do remember that we ran out of the glass jars that we had pretty early, and I remember ordering like a significantly larger quantity than Val had recommended.
Yeah.
So I was definitely surprised that we ran out like quite early into the event. We still had kids sort of like flooding in, just wanting to play with the sand and interact with it in sort of any way that they could.
It was like 1,000 small bottles.
It may have been slightly less than that, like 600-ish.
But you guys ran out in like 2 hours.
Yeah.
So that's like 2,000 kids per day. Absolutely insane. Okay, so we've kind of alluded to what the booth might be, but in your own words, from start to finish, what does a kid do when they come visit your booth?
So our booth is sort of to teach kids about how sediment might be deposited in like a stratigraphic column, I guess. And so we have these like small glass jars or vials that they can fill with different colors of sand to show that the sand will build up over time, and the different layers can show that like different maybe types of sediment may be deposited. And you can learn a little bit about like actual geological principles like superposition, where the older sand is always deposited on the bottom and the younger sand gets deposited on top of that. So amidst all the chaos, there is a little bit of geology that they can learn from it. And hopefully they took that away.
So you're actually our third EFMP booth volunteer / leader that we've had on the show. We've had DJ Supernoval and DJ Squared. That's David James, whose name is also DJ. He goes by DJ. Anyway, I have asked all of them the same question. What is your favorite color of sand that comes with everything?
My favorite color is purple, so I'm sure purple sand is pretty nice.
Is there a purple sand that's there?
Now that you mention it, I don't know.
Like, so I don't think there is.
Blue?
Yeah.
I'm sure if you could mix the blue and red sand and get purple, it'll be close enough.
Okay, wait. So are you supposed to shake the thing after you build it?
The way that Val explained it to me when she was introducing me to the booth was that if you shake it, maybe you could say it's like a metamorphic rock now.
Yeah.
It underwent pressure, temperature variations or something like that. But, it's up to the kids.
So they're
They
not
can make their own.
supposed to shake them, but I'm sure they're walking around maracas all day long.
Yeah, for sure.
Okay, gotcha. Speaking of metamorphic rock, we also mentioned stratigraphical. I don't fully know what this word means. Do you want to tell us what it means?
I think it just sort of refers to rock strata, which is the sort of sequencing and the order of layers of rock.
Mhm.
Because I'm not a geologist, I hope I'm not butchering this too badly.
I'm not a geologist either, so I won't even know.
But whenever you're sort of like out on a field trip or something, it's something that will bring up a lot. Like the stratigraphic column is sort of the record that pertains to a specific area, the type of rocks that are there, and it shows quite a really nice history of what happened in that area over time, so you can sort of tell about historic environments, which I think is pretty cool.
So it's almost like the tree ring thing, where like trees get another ring every year and you can like learn about their history from that, but this one's not a circle, it's only a rectangle.
Mm-hmm. And it's a little bit more incomplete because of processes like erosion and everything, so you kind of, there's a lot of piecing together the puzzle to figure out everything that happened.
The reason I'm thinking of the tree ring thing is because Elisa Liu, who I'm sure you've heard of, she was mentioning that she adds a bleach ring into her hair every year, and somebody like retweeted it and was like, oh, she's like a tree. So very, very recent news, the top of my brain. You know, she's an undergrad here. That's so cool.
Yeah, it's
You
really
like
crazy.
you go to the same school as her. Anyway, I have been told that there is a poster that goes with your booth that's highly informative. Did you have this poster this year, and did anyone read it?
This poster was nowhere to be found.
Oh no!
I'm sure
So it's
that
probably
it is
in
very
this room.
informative, and I would love to see it at some point.
Longtime listeners will know that we record the podcast in the storage room for EYU, so the poster is probably in here. But what I learned is that most kids don't actually read it. Like, the sand is incredibly distracting, and the line is huge, and they're really just happy to be there. Okay, well, now we know. That's one less setup thing for, like, the next person who leaves this booth. But anyway, the kids still learn about geology, poster or not. Were there any really cool questions or observations that the kids made that were really exciting to you?
It was a while ago, so I can't remember exactly, but it's always nice to see the kids who are sort of able to, like, when I'm explaining them, oh, do you know what superposition is? And they'll say something like, yeah, I learned it in one of my classes at school.
What kids are learning about superposition? That's obscene.
It's actually, I think the state of California is one of the few states that actually requires earth science in K-12 education.
Oh, that's right,
So,
yeah.
Yeah, I feel like that's common W for our state.
Okay, that's fair. I did learn a lot of earth science when I was like in middle school and high school, but I don't remember learning the word superposition. So props to these kids. That's really cool. Any like silly stories you remember about the kids? Any sand fights? Sand castles?
Ooh, by the time we were done and we ran out of the glass jars, there were a lot of kids who were fully just like having fun moving across the table.
Oh,
which,
yeah.
you know, I'm sure their parents were happy that they were entertained for the majority of the day, but it was a lot for us to clean up later.
Yeah. We won't mention the cleanup process. I walked by later and it was good enough to me. And nobody said anything about it. So it was fine. There's only so much you can do. It looks like a holy festival just ran through that section of the Court of Sciences, which is why we put you guys in a little more hidden area, also because of the massive traffic. Do you know if you're running it again this year?
I will totally do it.
Oh my gosh, yay! I know, that was one of the weird things about me becoming the president of the EFMP, was like, oh, well, I'm obviously not going to run the booth. I have other things to do. And then Ava became the president after me, and she's the speaker chair. DJ Honk, because she's a silly goose, also can't be running the booth because she's too busy running speaker. So awesome that we have you there. Your services are highly appreciated. Is there anything else you want to share with our audience about what it was like to run that booth?
Well, on top of myself, I appreciate the other volunteers that were
there,
let's
shout them out.
Helping out on that day. I think for the listeners, be sure to visit us next year.
Yes. Or don't, because they're going to have hundreds of people. You're going to have to push through the crowd. Well, I know this because I was trying to visit DJ Supernoval 2 years ago when she was running it, and I just like couldn't get to her. Like I was trying to take a photo with her and she's like, I literally don't have 5 seconds to take this photo with you. So it's a picture of me standing in front of the booth and she's like hard at work, and my partner's like, look, you and Val got in the same photo together.
That sounds about right.
But we are so excited to have the EFMP stratigraphy in a jar back again for EYU 2026. Again, that is November 8th, Sunday from 12 to 5. When you walked in, you were telling me that your DJ name is DJ Tsu, which I'm a fan of because we're both Taiwanese. Tell us a little bit about how you came up with that name, what it means to you, why Tsunamis.
So the name is currently inspired by a research project that I'm working on, where I'm using machine learning models to help generate early warning predictions for tsunamis, so the maximum height that the wave would be and the arrival time at different locations. And the goal is, of course, to sort of improve the systems that we have currently, which I will say they do work, but we can always be sort of working on finding ways to improve them.
If you want to hear more about this, we have another episode with DJ Size, that's Saeed Mohana, and what was funny was the day his episode came out was like the day there was a tsunami warning in Los Angeles. So I was really hoping that it was going to go viral from that. It did, as in it got like 10 views in one day. Amazing. But are you working with Saeed on this project?
So Saeed is a part of the same research group,
Mm-hmm.
but we're working on sort of different methods.
Oh, cool.
I think he uses more like pressure sensors or
I don't know.
Something.
You know, feel free to spread misinformation about him. What is he going to do to us?
He'll come for me later, but who knows? But we are taking a different approach. I think his is sort of data driven and uses like inversions to sort of find the tsunami information.
Mm-hmm.
My project is, at this point, it's like purely computational, and that I'm using like computer simulations to generate a lot of fake tsunamis that we can use to train a machine learning model.
Very cool. How did you get interested in this? Was it the machine learning aspect that drew you, or the tsunami aspect?
I think it was more the tsunami aspect. Previous research that I've done with my mentor has been more focused on like earthquake dynamics and sort of those hazards. And so I was pretty interested when he introduced this project to me and posed it. And because it is involving machine learning, I think that's a very, current, rapidly advancing field.
Don't I know it?
Yeah, definitely something that's really interesting and a little bit daunting to get into at first, but now it's very cool to be able to say like, yeah, I did that.
Okay, so since we're here and we can talk about this, can you explain to the audience the difference between you using AI and somebody using ChatGPT to like generate videos or something?
Yeah, so I think that to me it's kind of a substitutability thing. So we use AI to analyze a lot of data, do a lot of computations that would take a really long time for a computer to do, and that's sort of the basis of the tsunami project I'm working on, is that currently we have computers running simulations in real time to predict how strong a tsunami is going to be. But if we're able to use a machine learning model to do that, it'll do it a lot faster and be, maybe a little bit less computationally intensive when it comes to training and evaluating the model, or
absolutely
just testing the model and evaluating it.
Yeah.
And so when it comes to those sorts of things, I don't think that like any human is going to want to crunch those numbers or like waste all their computer memory on like doing these calculations, which is, in contrast to like the AI videos where we have lots of artists, animators, etc., who are very open and willing to, doing these projects that unfortunately these large language models are capable of now.
Yeah, absolutely. I mean, the training process can be minorly intensive, but the goal is that the final product expedites everything, reduces the amount of energy used, reduces the amount of computer storage used. That's the end goal for this. We are not making Italian brain rot in the basement of UCLA. Very cool. You mentioned that you were doing earthquake work before this. Is that in the same group? And please say your advisor's name again.
Oh yeah, that is in the same group for Dr. Lingsen Meng. And so with those sorts of projects, whenever a large earthquake happened, maybe like magnitude 7 or above, there are different sorts of analysis techniques that we can use in order to describe what happened during that earthquake. So I think a lot of viewers may be familiar with like identifying where earthquake originates as like a point on a map.
Yeah.
But I think the process is a lot more complicated, and it's, three-dimensional, as Earth is a very complicated system.
That's right.
So,
the depth of the
yeah.
earthquake makes a big difference.
Yeah, but not only that, the depth, but you can sort of see across an entire fault plane, like this rupture might propagate from the epicenter, maybe hundreds of kilometers in cases of like one of the recent earthquakes that happened off the coast of Russia. That was like a magnitude 8.8. So earthquakes are very complicated events, but we do have the tools to sort of describe them, which is very, very awesome.
So what was your role in advancing these tools?
I think it was mostly applying them to these different situations, and so maybe less of advancing these tools. It's using them to explain, I guess, the geology or some of the processes that might have contributed to causing the earthquake in the region.
Okay.
So I would sort of use what we call like back projection, which helps define where the energy comes from in an earthquake, or another technique would be like finite fault inversions, which can sort of show exactly where motion happened along a fault plane. And so using those techniques, I would be able to sort of generate an image of what the earthquake rupture looked like. And then I would work with some of the other grad students in our group to draw conclusions about, what does it all look like when we put those pictures together with some of the other data that they're able to collect.
Can you learn about like what kind of rock is there, like how compact it is?
Yeah, I think we can tell a little bit about maybe the fault surface and whether or not it's like really rough and so there's a lot of friction, or maybe if it's like smoother, something like that. And so now that's probably based off like the frequency maybe of the waves. So high frequency energy might come from a fault that is maybe subducting further into the earth, and so it's a little bit more like crumpled up, compressed, deformed, something like that.
Okay, quick geology lesson. There are three kinds of faults. Okay, so there's subducting fault, which is you have two things, one of them goes under the other. There's the one where they fight each other and become a mountain. What's that one called?
That's a convergent boundary,
okay,
which is the same sort of process as a subducting
yeah.
plate, where the plates come together, but
okay,
different behaviors if the plates are of different densities.
Because that one, they're the same density, so then they fight each other. But the subducting one of them's denser than the other, so one of them just leaves. Okay, and then the third one's the slip strike transverse.
And then the divergent one.
Oh, that's right. Oh my gosh, there are 4. So embarrassing. I definitely took earth science with the California school as a 6th grader, and I tried my best. This is for my 6th grade knowledge. I was hoping you would explain a little bit more about each type of boundary.
So there are 3 types of plate boundaries. What that describes sort of the relative motion of each plate. So we have the divergent boundaries where the plates move apart from each other. And this is places like in between Europe and North America. There's a ocean ridge that's forming where we're getting new oceanic crust as magma erupts from the mantle and solidifies. That's also causing these 2 continents to sort of move away from each other.
Goodbye, Europe.
Yeah, it's also causing Africa to split apart. So in many, many, many years, Africa
that's right.
might be in 2 different pieces, separated by an ocean.
Reunite Pangaea.
The second type is the convergent boundary, which could cause maybe a subduction zone, where if one plate is denser or heavier than the other. This is seen in places like the Pacific Ocean, and that's sort of what causes the Ring of Fire, where we have a lot of volcanoes in places like Japan, Southeast Asia, Alaska, etc., because the oceanic plate is subducting and melting and causing those volcanoes to form.
So the melting plate becomes the lava?
Yeah.
Okay.
Yeah. And then the last one is the transform fault, or transform plate boundary, where the plates slide past each other. And that's something that people in California will be most familiar with, because that's what the San Andreas Fault is. And even though it's, most really commonly associated with earthquakes, we can see earthquakes at other types of plate boundaries as well. And in fact, I think convergent plate boundaries, where subduction zones, can sometimes cause larger earthquakes than transform faults.
Okay, so the fun fact here is that the San Andreas Fault is actually a boundary, and faults and boundaries are two different things. Can you briefly explain the difference between faults and boundaries?
Yeah. Faults are a lot more common in that I want to say every plate boundary is a fault,
Oh,
but not every fault is at a plate boundary.
Okay.
Even within California, there are like so many different faults that I guess are just like places where rocks move relative to each other. But the same sort of motions apply. You could have the rocks like moving apart from each other because of sort of a pulling motion based off of plate motion. They could be like pushed towards each other or like sliding past each other in the same ways that plate boundaries move. But we do get sort of different geological features as a result of all those things. But I think a big driver of all that, faulting, folding, etc. is plate tectonics.
Awesome. We need a very quick definition of plate tectonics.
Plate tectonics is the theory that the Earth's crust is made up of these plates that are sort of moving around the surface and interacting with each other at those boundaries that we talked about.
Well, thank you so much. I feel so refreshed. I feel like I just finished 6th grade all over again, except I look a lot better now. Low-key, I had a glow up in high school and college. Speaking of which, let's hear how you ended up becoming this very well-decorated researcher and scientific outreacher. My guess is that you're from the Bay Area. I know you're a Taiwanese Weijan. These are all already really cool things.
Yeah, so I am from a town kind of in the Bay Area called Mountain House. It's a very small town. But I think that a lot of, I guess, my love for science came from my ability to do extracurriculars. Like we had the science fair, we had something called Science Olympiad.
Oh yeah.
Which was a pretty big academic competition. And that's where I was first introduced to things like earth science. And that sort of like, I guess, always stayed with me as like an interest. But throughout high school, I was able to interact with it a little bit less. And so I kind of forgot that like I appreciate it as much. So when I finally came to UCLA, I was an environmental science major because I was hoping to sort of work at the intersection of like environmental science and policy.
Very cool.
Environmental justice. And that's something that I still care about. But I think that there was something missing for me in terms of like something, I guess, like math and physics were things.
You wanted to do more math.
Yeah, exactly.
I miss integrating like every day. I'm always like, can I just integrate like an exponential function really quick? So I totally get it.
Yeah, so that was very real for me. And so I was very happy that I sort of I was enrolled in an introduction to earth science class here at UCLA as like an elective in the environmental science major. But I realized like, hey, I like this a lot. And so I talked to the professor of the class, Kevin Coffey, who I think is awesome.
Yeah, it's okay. Yeah. DJ Snowball Garnett. Big fan of him.
Yeah, so he was also on the podcast, and he was a really big part of like getting me to actually join the department. I think it was a really good decision because there's been so much support from basically everyone I've interacted with, like all the other students, the graduate students, faculty, etc. A lot of opportunities that I found like pretty happy to be a geophysics major now.
That's very cool. Do you want to quickly shout out any of the other faculty or grad students that helped you switch majors?
Yeah, I think on top of switching, but like keeping me in the major, helping me like enjoy it a lot, definitely my mentor Ling-sun, the current department chair, and one of my former professors, John Arnaud, was really engaged in sort of like our success, being passionate about geophysics, etc. There's one graduate student, I don't know if you know her, Megan Lee. She's been really influential and really supportive of me.
I have not done anything. I can't even do geology, but thank you. I appreciate it.
I think, being a part of like the EFMP community has been a big part of like sticking around.
That's right. We have to talk about EFMP on the whole. So you are definitely going to be the EFMP president next year. Tell us a little bit about how you got involved with the EFMP and what makes you so excited about its success.
I think I first got involved last year. I kind of saw a lot of advertisements about like tea time that was held weekly in the Commons room. And
Did you see like taped up flyers in various places?
Definitely.
Wow.
And always in my inbox, I'm checking my email.
I physically taped those up with I have a really deteriorating roll of Scotch tape in my office. Like, you can't get more than an inch off, so it was really hard to tape up those flyers, so I'm glad someone saw them.
They definitely worked.
Yay!
But I really like tea time as a way to sort of get to know people, because it's kind of like everyone in the department is definitely willing to come mingle at some point.
That's true. Because there's free food.
Yeah, yes, exactly. Free food kind of lures any. And so after that, I think there was another flyer for EFMP board members.
Yes.
And so I filled that out, and I think my first role was coordinator of social events.
I think so.
And so we did a few things last year, like we planned a hike, we did more tea time.
Oh, the hike.
And then we did the study-a-thon. So overall, just like a lot of fun ways to like get to know people and keep everyone involved.
Okay, the reason this hike is so triggering to me is like irrelevant from like the club and everything. It was just because it was right after the LA fires and everybody really wanted to go hike in Malibu, and it's like, well, the road to take you there isn't open, so I guess we're all driving 2 hours to go 10 miles. You were actually in our car at the time. So that's why every time people bring up the hike, I'm like such a Debbie Downer about it. But like, other than that, like, yes, go hiking, but can we please pick somewhere closer? And this year, I think you're planning something very big for this quarter. Feel free to keep it a surprise if it's supposed to be a surprise, but do you want to give us a sneak peek?
Maybe by the time the podcast is out, we'll have a flyer out about it. But we're hoping to get a bunch of people in different careers and sort of different stages of life to talk about their experiences to, I guess, either undergraduates or graduate students in the department. But a lot of, hopefully, geoscience role models that we can hear from.
It's going to be super cool, so please stay tuned to the EFMP Instagram. Also, if anybody wants to be the admin of the EFMP Instagram, I think the captions are awful and somebody needs to take over ASAP because they're extremely brain rotted.
But personally, I'm a big fan.
Today's captions were crazy. There were so many emojis in them. Anyway, you're also in a family in the EFMP with some very familiar faces. And someday you are going to be the leader of your own EFMP family. It's almost coming up. What are you hoping that younger students can learn from you?
I hope they're just able to be encouraged to pursue the geosciences. It was something that, because I was like passionate about it in the past, but I was a little bit uncertain about like whether or not it was something I should pursue further. So I think hopefully they will be encouraged to I guess like take the chance and dedicate yourself to it, and joining programs like EFMP and finding those support systems will be really good in terms of like keeping people engaged and involved, etc.
What I'm hearing is like nurture your passion. Like, it's one thing to like have it and like know what people are supposed to do, but you need to like put in the effort to really like grow your passions and make sure that you can thrive there instead of just survive. A lot of people are just surviving. Okay, so now we're going to do the bigger picture version of the same question. If you were a child at EYU, we're going to go all the way back to Exploring Your Universe now. If you were a small DJ Tsu, okay, that would be like a DJ like Splash. What would you have wanted to hear from an adult or a volunteer there?
Honestly, I think it would have just been nice to know that they existed in the sorts of like career fields that they're in and that they're, you know, enjoying what they're doing. As a child, I didn't have too much exposure to people like that. Both my parents work in the medical field, which is so respectful, and I, you know, appreciate them a lot.
Thank you, medical people.
Yeah. But I think being able to see everyone working in like the physical sciences in general, and seeing that they have a lot of like love for what they're doing, and the fact that they're doing a lot of really cool things would just be inspiring in itself, I think.
That's really good. You know, some other answers to this question range from like give them $20 or give them a snack, like tell them to invest in Bitcoin. So I really like this answer. I think that's very nice. And yes, some of us physical scientists are in fact having fun sometimes. Anything else you would like our listeners to know?
Come to EYU.
Yes, November 8th, then 2026. Well, thank you so much for joining us, DJ Tsu, and thank you for all the hard work that you put in to foster this beautiful community in EPSS and at EYU. And with that, never stop exploring.